The next slide. All right. So for today's webinar, we've got two awesome speakers. We've got Kurt Alaibeolu. He's a senior associate at the Chertoff Group. And prior to joining the Chertoff Group, he served as a cyber warfare officer in the United States Air Force and was responsible for planning and executing real-world offensive cyberspace operations with Joint Forces Headquarters Cyber and the National Security Agency. Kurt is a graduate of the United States Air Force Academy. He holds a master's degree in information assurance and cybersecurity and numerous professional certifications, including SANS Certified Penetration Tester, Incident Handler, and ISO 27000 Specialist. We've also got, with nearly 20 years of industrial automation experience, Austin Scott, who's a principal industrial penetration tester at Dragos, where he identifies ICS cyber risk. Prior to Dragos, Austin worked as part of the industrial cybersecurity team at Sempra, Shell, and as an industrial cybersecurity consultant at Accenture. Austin is a 2015 SANS Cybersecurity Difference Maker winner for his industrial cybersecurity contributions. In August 2018, he won the DEF CON ICS Village Hack the Plant competition and was awarded the DEF CON Uber Black badge. So without further ado, let's let Austin take it away to introduce today's topic.
Awesome. All right, you're still on mute, Austin.
Thank you so much. Appreciate that warm introduction. Today, we're going to be talking about this unified IT/OT risk management approach. We're going to get into some of the background about MITRE ATT&CK, attack for enterprise, and attack for ICS, and how we can use those to better understand the activity groups that are targeting ICS today and how they might move through sort of stage 1 and stage 2 of what's known as the ICS cyber kill chain, and how to shore up our defenses and ensure we have detections at each of these stages along the way. And we're going to talk about sort of the practical application for building this converged program that we've done in the past with the Chertoff Group for real customer engagements. And we'll also share some useful resources at the end. Now I'll kick it back to Kurt to take us to the next through the next slide here.
Sure, thanks. So what does risk management look like for IT and OT? Because risk doesn't care whether it's IT risk or it's OT risk. For most companies, it's just risk. And there's a methodology that focuses on this sort of virtual cycle of risk assessment, risk mitigation, and risk monitoring. And so what we try to focus on in this case, as we mentioned, for those companies that do have to, and organizations that have to deal with both IT and OT, IT environments tend to be a stepping stone or a way into OT environments. You see very little scenarios where attackers will directly penetrate IT environments. And so what we look at from a perspective of looking at converged risk across both of these is to look at first, okay, let's assess what are our inherent risks, and that involves like, okay, what do we produce? What is our the item that we produce, and how does that attract other attackers, other threat actors to targeting us? How do we then identify high value data assets, things that are essentially our crown jewels in the IT environment, and looking at assessing IT systems and threats, vulnerabilities that are associated with that. And then from there, okay, now I know who's interested in me. I know hopefully what they are interested in when they are planning on targeting me. And I know what threats, what vulnerabilities they can try and compromise in order to get into that. So from there, then we move on to mitigation. Okay, so this kind of seems normal for most IT ops. Is you look at an IT security, you go and look at, okay, what are my vulnerabilities? Okay, now how do I go and how do I mitigate them? But where people, we notice, tend to fall down on is the continuous monitoring aspect of it, and that's looking at how do we make sure that that the controls that we have in place are in fact effective. and they are in fact protecting us from the things that we expect them to do. And that includes things like testing and exercising security capabilities. Many people look at this synonymously as penetration testing, but it's not just penetration testing. It's looking at controls assurance. It's auditing. It's looking at individual controls, and not just looking at, can I pwn your domain controller, and then from there, can I pivot into your OT environment? 9 times out of 10, the answer to that is yes. But what's more important to get out of that is, okay, what value can I extract from that? How does red help blue in this aspect? And this is not just an aspect that's unique to IT. We can apply this assessment, mitigate, and monitor aspect to what we do on OT. And I'm going to pass it back to Austin to talk a little bit on the OT side. And then we're going to talk a little bit about how we've taken this converged model, and we've used this on several occasions now with several customers.
And certainly on the operational technology side, you also want to take a threat-based approach, a risk-based approach to understanding what the adversaries are capable of. It helps to narrow down from the infinite combination of different possibilities. We can see what people have done in the past and look to defend against that. And we also have to understand our environment as well. What are the crown jewels of the site we're defending? If it's a pasta factory or something like that, you might have the trains that load all the grain, or the mill that crushes all of the grains to make the dough. Or if it's something more critical, like a gas pipeline, your turbine control computers, your compressors are going to be pretty critical to that process. So you want to understand what you're trying to defend. Even we had one assessment we did where there was a rabbi that was critical to the operation, because that plant was making kosher foods, and if the rabbi can't dial in, if he can't bless the food, then you got to shut the whole process down, because you're not making kosher food anymore. So it's really each process is different and unique, and you have to understand what the critical aspects are, and how impacting those would affect the process, put people's lives at risk potentially, or cost a significant amount of downtime or real money. And then to mitigate these risks, we want to understand what controls are in place, how vendors and other users are accessing the OT environment from the IT space, how remote management and maintenance and support from the vendors is put in place, and how we can shore up the defenses there. Things like network segmentation and protecting, putting controls around these crown jewels is going to be really beneficial, and will help reduce our risk. And ultimately, you want to monitor once you put these controls in place. Certainly prevention is ideal, but detection is a must. Certainly a bit of a cliche, but still resonates true and resonates within the OT space. So understanding what's going on in the environment, what these proprietary protocols kind of look like, and what's normal versus an abnormal action or state in those environments, and what threat behaviors might look like, those A plus B compound detections that can be used to identify the subtle differences often between malicious threat actor and the day-to-day operations of a plant.
That rabbi story is awesome. I didn't realize that was one of the process things that we looked at. I do remember a few times that when Dragos and I, when we were working together on 2 particular engagements, but it's, again, looking at the process in this case of many times on the IT side of how often technical vulnerabilities will get compromised, but then moving into the OT side, and it's more about compromising process always. It's always about looking at how do I stop organizations from make, move, and sell. And it's oftentimes not about using an exploit, but it's oftentimes where are those single points of failure, and how do I leverage on them? And so we saw that on 2 cases, and one was on a basically what was supposed to be an air dryer, and how it was incredibly important in this case to make sure that the air that was coming through for a particular process had to be completely have no moisture in it. And it was through almost a whole day of questioning of some of the engineers. It was like, so you're sure there's no, I mean, the redundancies in place here? Yes, it is. And then, by the end of the day, well, except for about 2 weeks ago when we had to shut down the process because there was water coming in the process. So, but we've looked at this from a process perspective for multiple organizations. So let's take a look at threat first, since we mentioned a bit about that. And it's, well, I guess let's start with MITRE ATT&CK. That's probably a better place to start for those who don't know what it is. So the cybersecurity community, for a long time, we've used a kill chain. And this, I say kill chain because this was actually monikered by Lockheed Martin. And it was a focus on a sort of 5-step process to be able to look at every single compromise that occurs. And it often involves reconnaissance, some sort of initial access, establishing command and control, laterally moving and escalating privileges in order to get to the location that you want and have the privileges you need in order to accomplish that task. And then it's either exfiltrating data, corrupting the data, or destroying the data, or manipulating the data. In the military, it's actually called D4M, deny, degrade, disrupt, destroy, or manipulate data. Well, what MITRE ATT&CK does is it essentially takes that kill chain, this two-dimensional or one-dimensional aspect, and pulls it down into 2 dimensions. And it takes those different steps into, okay, we have tactical goals or tactic categories, which is initial access, execution, defense evasion, discovery, privilege escalation, etc., going all the way to exfiltration or impact. And then below that, you've got different tactics, techniques, and procedures, and now sub-techniques with the new version of MITRE ATT&CK that go into the how. So if the tactical goals are the why, or what is trying to be accomplished, the TTPs below, that's the how. That's how did I accomplish privilege escalation? I accomplished it through account token manipulation, through account impersonation and theft. How did I accomplish discovery? Well, I did, netstat tech, BANO, and pulled all of the active network connections that are on the machine. So that's what MITRE ATT&CK does. And it also, on top of giving the how and the tactical goals, is also a great threat intelligence repository. And this builds into the threat aspect, and knowing who is interested in you comes into play. One of the things that most consumer organizations don't do is they don't look at threat from an aspect of who is interested in me. I produce this good, I make, move, and sell, whatever this is. Based on that, these threat actors have an MO, a modus operandi. They're interested in something. And the same group that attacks a bank is not going to be the same group that attacks a electric power generator or a gas refinery, or et cetera, et cetera. And it is this aspect that up until ATT&CK and sort of a lot of these other large repositories of threat intel have been able to sort of come together. Up until this point, we haven't been able to really get a good handle on being able to have the information and say, okay, based on the fact that I am a electric power generator, I know xenotime and et cetera, and these groups are interested in me. In the military, we actually look at that from a mission planning perspective. We say the commander wants to know, what are my adversaries' most likely courses of action and most dangerous courses of action? And that's all I'm interested in. So let's actually, from there, now that we've talked a bit about ATT&CK, let's move on to the next slide, where we start to look into what that down selecting looks like. So in this case, for this talk, what we've done is we selected the energy power generation sector as an example for the threat modeling process. So from there, we took a combination of both open source threat intelligence and also proprietary threat intel from Dragos' Worldview platform. And we put together a list of groups that have compromised OT SCADA environments before. And then we filtered those groups down into those groups that are interested in specifically energy and power sector. Also based on geopolitical considerations, because you're not going to often see, unless it's a government-sponsored APT, which is always the boogeyman that everyone's worried about, but you're not often going to see, say, the same organization, like I said, in Czech Republic that is doing ransomware attacks that are necessarily going to be immediately interested in attacking a power sector in US, unless it's just an opportunistic attack. And so we have to plan for those things that are targeted and also that are opportunistic. And so we bring these groups down here of the targeted list of those groups that have focused on energy and power. And now from there, what we can do is we can go in and look, okay, so what tactics and techniques have these groups used before? How have they accomplished their goal? So from there, we're going to take this and we're going to actually go a bit into attack for, so we talked a lot about attack for enterprise and how these groups have targeted IT environments as a stepping stone to get into OT. But now we're going to go and talk, I'm going to pass this back to Austin. We're going to talk a bit about attack for ICS, which is relatively newer, but has a lot of overlap with attack for enterprise. So back to you, Austin.
Yeah, certainly. Thank you so much, Kurt. And attack for ICS really gives us this encyclopedia of threat behavior that's targeted ICS systems in the past. It helps us to make this more of a solvable problem. Although no one's really solved it yet, it narrows down the scope quite a bit. So MITRE has spent a number of years doing all the research, collecting all the bits of information from every known OT attack since the beginning of time, basically, and have put them into this attack for ICS matrix. So it really helps to narrow things down. When you don't have like a construct like this to look at, it becomes a very difficult problem to address, to solve, because there's just sort of an infinite number of possibilities. This really narrows down the possibilities to things we've seen in the past, and we can use that as a threat model for OT systems. But why why build a separate OT attack for ICS matrix and model? Why would we need that? Well, these OT systems are very different than your typical IT systems, and there are a lot of people in the industry today who are perpetuating this I believe to be a false narrative around it's all just technology. Everything's the same. Like your OT and IT systems, it's all technology at the end of the day. And I think that's sort of a naive approach. I bet the person who's saying that has never plugged their laptop in next to a giant vat of hydrochloric acid, or ever worked on a system that's manufacturing children's Tylenol, or worked on a gas.
That's being managed by a machine that's still running Windows XP, or in some cases Windows 3.1.
Yeah, exactly. These environments are very different than IT systems, and you really can't treat your like Mark V turbine control computer that was built and engineered in the 80s and is now connected to this whole ICS network. You can't treat that like a SharePoint server, or you're going to have a bad time. There's a different approach that we take from a safety perspective when we go into these environments as well. There's a lot of life safety and consumer safety and product safety that you need to take into consideration before you even show up to one of these environments. Like you don't show up to an OT plant with your flip-flops and your cargo shorts and call it a day. Like there's protocols and procedures that you need to follow. And you need to keep that in mind with whatever you're doing, and be really clear about communicating to the operational staff. What we see, if you've ever worked in enterprise security, like a lot of these tools that we use for vulnerability management and scanning, they take down enterprise systems all the time. It's a constant problem if you're on the vulnerability management team of your scans or the different tools you use. They're interfering with the IT systems that you run, but no one really complains because you reboot your SharePoint server, you reboot your SQL Server database, and everything's fine. But you can't really do that in ICS systems. That when they were engineering these systems many years ago, in a lot of cases, they didn't really take into consideration like an Nmap scan or some kind of scan against a critical system like a turbine control computer that would take it out at a weird position. Like they never really considered that possibility when they were building these systems. So you have to keep that in mind, that these environments are different, and they're different from a defense perspective, and they're different from an attacker perspective as well. So let's take a look at some of those differences And certainly there are some overlaps between the enterprise attack model and the attack for ICS model, but they kind of end at that DMZ level. They end at that transition between IT and OT. Once you get past sort of the DMZ SCADAs, the historians, and the Windows machines, you get really into the process computers and into the HMIs and the PLCs and the real equipment that's operating in the cyber physical. There are real physical consequences to events or disruptions, and it costs people money or maybe their jobs or maybe even their lives when things go wrong. So people in these environments are understandably cautious, and they need to be careful with this equipment.
As Austin said, it's one thing if the Exchange server goes down for about 10, 15 minutes. I mean, business will continue if you don't have email. But it's another thing if the safety integrated system gets shut down while active processes are in place, people could die.
Absolutely, and that's exactly what the adversary Xenotime was trying to do with the whole Trisys event. They were attacking the safety system. They were trying to blind that safety system so they could create some kind of cyber physical effect. Or if there was some kind of safety incident, like a fire or something at the plant, that safety system wouldn't be able to jump in and do its job and protect the life safety instruments, and protect the people on the plant. So we did some analysis of the enterprise versus ICS model, and there's about a 25-75 overlap. About 75% of the techniques are unique and would only really apply in the ICS space. And just like attack for enterprise, there are tactics. And under each tactic, there are a number of techniques. And just like we talked about earlier, this is kind of the breakdown of what's known as the ICS kill chain. There's stage 1 would be on the enterprise side, and stage 2 is on the ICS side, where in the ICS kill chain, we see a lot of differences. The adversary has to do a lot more dwell time if they want to in the engineering process of that side, and they want to have a real impact, like Xenotime or Electrum. They spent months or years just dwelling in their OT environment, understanding the technologies, understanding the process, so they could hack the engineering rather than the actual Windows systems or IT systems. They're looking at finding ways of getting the process to eat itself, to self-destruct. And that takes time because every control system is different. There's different challenges, different vendors that are used, different technologies that are used, and different problems that they're trying to solve. So you need to understand the engineering side, understand what that solution looks like in its entirety before you can really work to impact that in a significant way. Anyone can kind of roll out ransomware, but if you really want to have a serious impact on an OT environment, it takes a lot of time and research to get there. So let's move on to the practical application and building this threat model.
Yeah, and so speaking on that dwell time aspect, that's what makes it so important on the IT side to be able to identify those threats. If you can't identify them before they get into your OT environment, then to at least identify them before they have enough time to be able to have that dwell time, to be able to conduct that discovery, and to be able to make that impact that an organization is attempting to make. And so, as I mentioned before, threat modeling is essentially the same statement that I made. What are my adversaries' most likely and most dangerous courses of action are? And I'm trying to take the universe of everything that they can do, and I'm trying to shrink it down into what answers that. And we do that based on, okay, well, we mentioned our adversaries before. It was like Allanite, Xenotime, et cetera, et cetera. So let's go for each of those groups, and let's see what tactics, techniques, and procedures have they used before. And we can do this using the attack navigator, which is we're going to show that in the resources afterwards, but MITRE has provided this attack navigator, which allows you to select by groups and it will highlight those TTPs that those groups have used in the past. But then additionally, we can also add on to that some other what I like to call ubiquitous tactics, techniques, and procedures. And those are those TTPs that everyone is going to do because there's a high information to noise ratio that is done where if someone runs IP config on a machine, no one's going to run any detections on that because they're going to be drowned in false positives and normal IT noise. And so those are your techniques. Like, everyone's going to do discovery. Everyone at some point is going to attempt to dump credentials. Everyone is going to attempt to do some form of initial access, most of the time phishing, because it's the easiest and low effort way of getting. But so once you get this model together of known TTPs that have been attributed to these groups and ubiquitous TTPs, and you bring this together, now I can start saying, okay, so which of these TTPs are critical for me? Because even within this shortened list, there are going to be things that are going to be much more difficult for me to address than others. And at TCG, how we like to look at this on the IT side is we use a combination of difficulty to defend. And that's based on, like, okay, what is, what are the things where even when you look at MITRE, like, there's no mitigation for this. This is a normal abuse of a normal OS function, and your best bet is detection. Okay, well, that goes to the hardest. And then what can we go to see what is at the level of, hey, this is cyber hygiene. Everyone should be doing this. So we take easiest to execute and easiest to defend, and we focus on those, because easiest to execute means that, hey, we're going to be seeing it a lot. If it's easy to do, you can bet everyone's going to be doing it. And if it's easy to defend against, then that means I have less effort that I need to put between personnel, resources, to be able to address, at least to create detections around these techniques and to focus on those. And that's kind of what this looks like here, looking at critical and high techniques. And so from there, we can start to take a very deliberate approach to creating detection analytics and to focusing on, do I even have coverage on these TTPs based on what data sources am I collecting on? Am I collecting on the logs that are relevant for these TTPs? Do I have the analytics necessary within my SIM or within my EDR to be able to even focus on some of these TTPs? That's where you can start to really dig into and create meaningful changes in your IT environment by being able to continue to narrow down into those that are most critical and that you can focus on. I noticed there's a question on the what the red items are. So the red items, those are, so all of the TTPs that you see here, that's the combination of threat groups that have attacked or have targeted electric power generation before. The reds, those are what we deem as your highest criticality techniques, going from the red on white being really, really critical, and you definitely should be focusing on these, going down to the lighter reds, which are, hey, that starts to become either it's a little more difficult to execute, so you'll either see it less, or it may be a little bit more difficult to defend against, and you may be spending more time and more effort in attempting to defend against those. So that's what that red on white is. And so from here, you take this and you say, okay, now I've got this for my IT environment. Now I need to go and look at this overlay, and what does this look like for OT? How do these two things overlap? And so I'm going to pass it back to Austin to talk to attack for ICS.
Thank you, Kurt. And again, we have the attack for ICS matrix here. We can see the tactics along the top and the techniques under each tactic. And it does make like a kill chain all the way from initial access to impact from left to right. So we can see this really represents the stage 2 of an adversary attack. And we've highlighted only the techniques that we've seen being leveraged by Electrum in the past, in the 2015, 2016 Ukraine events. So if we're able to narrow that down from the infinite possibilities of what an attacker might do, it really helps us to build that defense in depth. Now, if we start to do some analysis on what our capabilities are, where the gaps might be, there's lots of different ways you can slice this. And honestly, I've been doing this basically full time most of 2020 since COVID hit. I've been doing a lot of these scenario developments and threat modeling using ATTCK for ICS full time, and it's been a blast. And it's been really revealing. Like it helps us to understand where the capabilities are within our product, and also for our customers, building these models out for our customers and running these scenarios in a tabletop exercise or in an assessment can highlight where they need to shore up their defenses or where they have enough. We can see here in the earlier stages of the kill chain under evasion, discovery, lateral movement, we've got some good capabilities. But as we get further down the kill chain into the ICS side, we might be able to detect some of these things: loss of control, loss of view, program download. But we might not be able to really respond to it. We may not have the forensic capabilities to look at these programs or things like that. So it's good to take an honest approach and look at your capabilities against a specific activity group like Electrum. And we can cut this all sorts of different ways. It's a great way to really narrow down the conversation and crystallize that discussion around particular techniques. We will even do some versions of this where we'll show these are the number of detections or number of controls we have in place for each of these different techniques and under each tactic. So you can see where your defensive depth is strong and where you might want to short some things up, or maybe it's good enough. Maybe, if you have enough of these across the matrix, enough detections, you'll definitely see an adversary as they try some of these commonly known techniques in an environment. So being able to detect those and alert on them is key.
Yeah, the idea here is not to focus on this. I should add that as opposed to attack for enterprise and looking at attack for ICS, what you're seeing here, this is actually the entirety of attack for ICS currently. Whereas the entirety for attack for enterprise is actually much larger. What I was showing before is actually a smaller snippet of attack for enterprise. And the goal here, as Austin said, it's not to have full coverage on everything across, or it's not even to have full coverage on everything that's within your threat model, but it is to create enough defense in depth, especially early on, to be able to make those early detections and be able to get a human to put eyes on those detections and say, is this something where I need to do incident response triage? Is this something where I'm not looking at my, I'm in my SOC and looking at my dashboard and I'm having all of these alerts pop up, and it's that ability to get just enough information in to say, this doesn't look right. I need to go and look at this machine and I need to start incident response. It's to create enough of those hurdles to trip up an adversary so that you can catch them on earlier, because as you go further down the kill chain, it becomes much more difficult. It's much more difficult to prevent an attacker from encrypting your drive than it is from catching them when they're attempting to establish persistence or attempting to escalate privileges so that they can do that. You're going to spend a lot more resources in trying to stop ransomware at the point of detonation than you would attempting to on the earlier stages of the kill chain. And the same goes for ICS as well. Is the earlier on techniques tend to be, I'm generalizing, Austin, you can correct me if I'm wrong, but earlier on in the kill chain, you have a much better chance of being able to detect attackers than you do as you go further down the list, hopefully before you get to the point where attackers are attempting to inhibit response or impair process control or make an impact to the process.
And that's true to a certain extent. You really need to understand what these proprietary protocols look like, and when you're seeing some unknown or strange message types going to devices. A lot of time, the attacks, especially Electrum, they look a lot like normal operator behavior. So you need to rely on the context of some of the other techniques in the matrix to create some more sort of compound analytics that puts like a program download in context from a malicious actor attack, right? Program downloads happen all the time. Command messages happen all the time, but if we're seeing some of these earlier stage discovery, remote system discovery or remote file copy, and then we see a program download and then a loss of view, loss of control. That looks like a kill chain. Suddenly that normal looking program download isn't so normal anymore. So having coverage across the kill chain gives you context in the attack, because it's not always possible to distinguish attack behavior versus
normal behavior,
normal operation.
Yeah, that was the additional thing I had to add. Sorry, let's go ahead and continue. So, in summary, applying attack and building a converged program is not much different than what you're going to look at in the case of building that threat model out and looking at the protections that you have. This is risk, and risk doesn't care whether it's IT or whether it's OT. It's all risk. And so looking at unified threat model of what are the organizations that are interested in me? Why are they in fact interested in me, and what have they done in the past? And then it's looking at, okay, now that I know what they can do, it's looking at the controls I have in place. And it's not just, oh, we're missing control X, Y, and Z, we need to go out and buy it. No, buying a widget is not just enough to be able to protect you. It's also looking at the widgets you do have and testing them to see, are they doing what I think they're supposed to be doing? Because oftentimes the case will be is, as you run tests, you uncover that, hey, widget X, Y, and Z that we purchased last year, turns out it's misconfigured, or turns out we don't have enough analytics, or it turns out we haven't tuned or optimized it to our environment. And it's looking at that controls assurance and optimization aspect, both on the IT side and on the OT side. And then from there, it's taking that planning and resources that you've done, is bringing this information, this reporting up to leadership so that they can make these risk-based decisions, and so that they can turn around and provide the resources that are required to be able to make meaningful change in an organization, to be able to change those, when you provide those reports up to the CISO or the CSO, that looks like seas of red, that we're not necessarily in a good position, but to be able to say, with X, Y, and Z changes that we can make meaningful changes and turn these from things that we can't see anymore to now things that we can see and we can act on.
Yeah, certainly management loves dashboards and visual,
Oh, yeah.
And the matrix is a great way of visually showing, okay, this is what your system looks like with these controls in place, and this is what your system looks like with those controls in place. This is the defense in depth we have before and after. So we found that to be very, it's a great conversation piece, I guess. It's a model. No model's perfect, but it's the best we have. MITRE's done a lot of work in pulling all this information together. So at the very least, you can take advantage of all that time and effort they've put in to collect all this data into one sort of Wikipedia or encyclopedia of industrial threat behavior. So we're very grateful for all the work they've done, and we really are seeing the benefits since it's released this year.
Yeah, I think the saying was, all models are wrong, but some models are useful. This definitely falls into the useful category, both for IT and OT, to be able to explain exactly where you are and to kind of remove some of that fog and friction of the unknown. So from there, I think what's left is we've got these resources available, and someone had asked before whether the slides are going to be shared. Yes, they will be, and I think Aiden did answer that. But some useful resources if you haven't played with attack and you want to start learning, we've got the link to the attack navigator, which is what we use to build those attack for enterprise, the IT side, on building those threat models and mappings on them. MITRE has a GitHub that has a bunch of useful scripts. If you know a little bit of Python, you can start working with them to be able to pull mitigations that are associated with TTPs and how you can start implementing them. There's the primary GitHub there. There was a great talk. So I mentioned we use difficulty of attack and difficulty of execution. There's actually a great talk done by Travis Smith at the first ATTCK on attack as a teacher. This is actually the basis for kind of putting the different TTPs into ordinal levels of difficulty of execution. and he still maintains with even with the newest version of ATTCK on what those ordinal levels are. And then there's also the link for ATTCK for ICS to be able to take a look at that. So obviously this will be shared, but this is a great place for people who've never used ATTCK before to be able to get started. And I think that's all we have.
Yeah, so we do have a couple minutes to run through some of the questions that we've been gathering up throughout the course of the presentation. I am wondering, I just noticed that Austin kind of grabbed hold of one of the questions from Jeff. Where does the ICS chain start? Is it at level 3 or 3.5? Did we answer that one already, or does one of you want to take that?
I'll jump in real quick. Now, the kill chain and ATTCK for ICS are, of course, two different things, but we talked about them together in this unified threat model in today's presentation. And there's a lot of parallels that can be made between the two of them. So the ICS kill chain definitely starts at 3.5, but the ATTCK for ICS actually starts up at level 5 with the initial access. So how the attacker gets into the enterprise is interesting and useful information for that entire kill chain. So that's where a lot of that overlap occurs between ATTCK for enterprise and ATTCK for ICS, is in that sort of initial access. How did the adversary get into the enterprise environment or into the OT environment and pivot in, or what does that crossover look like? There's different starting positions for the kill chain versus ATTCK for ICS.
In this case, because there is such overlap, I mean, and as we said, most of the time, enterprise access, the stepping stone, is the reason why it sort of ties together that way.
Great. So Diane asks, does MITRE have a rating associated with the different attacks?
So MITRE does not, and I don't think MITRE will create their own rating that's associated with that, because criticality, so as I've stated, how we assess criticality, and also there's difficulty of execution, difficulty of defense, but in many cases, some of those can be subjective. What I didn't mention in terms of difficulty of defense is you've got your basic hygiene, and you've got your hey, this is a lot of work for not a lot of return on investment. Then you've got this big squishy section of your mileage may vary in between, which can be very dependent on your organization's individual operating constraints and environment. And it's difficult to put out this sort of, if you will, encyclopedic, this technique is a 5 on criticality, whereas this technique is a 1. A lot of that is going to be subjective, and we try to objectify the information as much as possible, but there's always going to be that limitation. And so yeah, they do. Short answer, no, they do not. And Kurt's personal opinion, I don't know that they will get there, or if that, I don't think that's even on their radar to try and establish that.
Great. Abdullah asks, are there any ICS forensics products that attempt to track down the exact source of ICS attacks? If yes, how successful are these products, and how do they do at a high level?
So certainly in the realm of Windows forensic, that's a well-known industry. There's lots of tools that provide forensics for Windows systems, but for ICS, that doesn't really exist today. And there's a challenge there because there's just such a wide range of technologies and vendors in the space, and performing forensics on PLCs and looking for malicious code in the firmware or the actual software program that's being loaded onto those devices. Those tools don't really exist yet in the industry. However, there are techniques that can be learned to pull that data and do that kind of that hardware analysis, that firmware analysis of these devices. But there are no out-of-the-box tools like we see in the IT side for forensic analysis in OT.
Got it. Our plant manager is claiming their ICS is air-gapped. The thing is, how do we verify this information without compromising the production?
So you need to do some analysis of that environment. I've encountered a lot of air-gapped systems in quotes, just like that, that turns out are not actually air-gapped. Usually there's some vendor connection in there for monitoring or a historian connection that they had kind of forgotten about or didn't realize was in place. So you need to take a look at the switch configs and the firewall configs to understand how that routing occurs, what that air gap really looks like. So you need to do some analysis, get on those machines, just see if you can safely ping out into the corporate network. Often you'll find that there are connections that were unintended or were added over the years that people didn't realize exist in these ICS air-gapped environments. Unfortunately, the data is so valuable in these environments that it's difficult to really air-gap them. You want to have that real-time information because for a lot of companies, the process, that OT environment is the cash register for the company. So everyone's going to want access to that data. So it's really difficult to truly air-gap these ICS environments. So, I mean, almost every system that we've done assessments on that claimed to be air-gapped wasn't really air-gapped in my experience.
Or one way. I mean, that was, and I've done far less than you have just in working with you guys, Austin. But in the one of them that I mentioned before, the claim was that data was only one way. It was coming out of the plant, and we asked multiple times, well, let's look at the firewall and the router configs and let's see if that's the case. And sure enough, a quick look of the firewall rules were enough to say, well, but look here, you have an admin connection that's allowed from here. Oh, we didn't know that was there.
Yeah. Sometimes there's temporary firewall rules and stuff that are put in place during commissioning, and people just forget about them. So it's good to do an assessment of those rules and understand what's going in and out of your environment, or just doing some monitoring of the data flows. If you can get in there to collect that information, you'll quickly see what's chirping out, what's actually going out of the OT environment. Absolutely. And what's coming in.
So John asks, how does an organization measure defensive effectiveness?
So, I mean, there are a number of ways. When looking at individual techniques, so if we're using ATTCK as the tool here to be able to measure, if you've gone ahead and built out your threat model and you have controls that are in place and you're looking to test against them, I mean, you can start with almost as simple as we passed these tests and we failed these tests. And that can come from a number of different ways. I mean, Red Canary has produced like the atomic red team testing that you can start doing like without any tools, just open source. You can grab information, grab the scripts and start running them to see how you would react or how your controls react to running certain tests. But then as you get more advanced, you can start looking at bringing in penetration testing, red teaming, controls assurance, auditing, to be able to look at the controls that are in place and see, okay, how am I doing on an individual basis? But then afterwards, once you want to start to become a little more advanced on that, as I mentioned before, there's the criticality ratings where you can say, okay, well, these are the ones I want to focus on. Am I passing or failing these? And those are the ones that I want to remediate first. And then from there, it becomes a short step to saying, okay, now I just need to risk rate these. I need to put them in an ordinal level where this one's my most important, this one's less, and going down to all the way less. And then from there, it just becomes a short step to, I can create a score from that. And I can look and say, I passed these, I failed these are less valuable, so that's important. I passed the important ones, so I can turn around and say, hey, in simple terms, we are at a 70% level of readiness. Now, the number itself of the percentage doesn't really mean anything. It's the effort that went into rating those techniques in terms of criticality and being able to assess for your organization what is important and to be able to justify that importance. And as long as that justification is sound, the number stands on itself.
And certainly the keyword there is effectiveness. I believe the only way you can really measure the effectiveness of your controls is to do an actual assessment, an architecture assessment or a pen test. It's one thing to have controls in place, but those controls aren't always effective. They may not be configured properly. They may not be set up, or there may be disconnects or problems with that. we've run into situations where, there's AV deployed out in an OT environment, and sure enough, when we trigger that AV, it doesn't go anywhere. So just because you have the controls in place doesn't mean they're effective. So you have to actually, to test the effectiveness, you have to actually test the controls, and you have to do that in a safe manner.
Yeah, perfect example of that is in one of my first assessments that I did. The organization had went and purchased a very expensive anti-DDoS tool, and then sat on the shelf for about 6 months, but they had it. Then when it was finally installed on the core router, it was configured on a span port, which meant it's like, yep, I see the traffic. There it is. There it goes. I can't do anything about it because I'm not in line. And these are the types of control optimization issues that can be identified by doing those analyses and doing those, I like to call them controls assurance tests, to make sure, basically kicking the tires and making sure it's working like it's supposed to.
All right, so we have about 5 questions and 5 minutes to spare. Not sure we'll get to everyone.
Lightning round, let's do it.
Yeah,
Good.
lightning round.
Do you have any recommendations for advanced object-oriented tools in threat modeling, e.g. STRIDE as the traditional entry model?
Ooh.
So, ATTCK for Enterprise, ATTCK for ICS can provide that threat modeling tools. They do have their navigator and some other tools. Although it still has yet to be added to ATTCK for ICS, it is coming soon. So those can help you build out those threat models and custom threat models, similar to STRIDE or other traditional models.
Yeah, and on that, by the way, all the modeling files that feed into Navigator, they're all JSONs. So if you know your way working around JavaScript object notation, you can work with those and even write your own scripts to modify them en masse. We do it all the time. So
great. Are there any implications for organizations that are pivoting from ISO 27001 to CMMC compliance?
So compliance frameworks are great as a tool to be used as a checklist to see, am I doing these things? But I mean, I think Austin, you'll agree with me. Compliance does not necessarily equal security. Moving from one compliance framework to another is going to offer administrative challenges in terms of being able to measure out what performance looks like against the controls that are in place for that framework. But in terms of causing issues or improving or weakening security posture, it's only going to identify what you already do or do not have in place.
And it helps free up resources. In my experience working with other compliance frameworks like NERC-CIP and stuff, it will get you the resources you need to solve a lot of problems once they get identified. So it's a good thing. It doesn't equal security. Compliance doesn't equal security, but it does help.
Yeah. No, yeah, exactly. It's useful as a tool to identify what you do and don't have, but then from there it becomes a question of, okay, I do have these things. Does it work?
Mm-hmm.
All right, I think this will be our last question. I've heard that ATTCK can help with red team, blue team collaboration. Have you found that?
Absolutely. Because, one of the things that was so difficult before is, and one of the things we didn't mention here, but ATTCK also provides a common taxonomy. It's good for a common framework to even talk about what is happening. I accomplished privilege execution by access token manipulation. That means something. And when red team can use the same language to explain to blue team what happened and how they accomplished what they did, then mitigations can come back and say, okay, I want you to do the same technique again. I want you to run privilege escalation via account token manipulation or via process injection. And then go around, turn around and test that. And then you can take that same language and then go take it to C-suite executives who may not necessarily be technically savvy, who may not necessarily understand what process injection means, whether that's a DLL injection or whether that's a PE injection won't mean anything to them, but they will understand when you turn around and say, we prevented privilege escalation via code execution after we did 5 tests with red team and blue team, and we were able to come up with mitigations that prevented that from happening. And we were able to apply that across the enterprise.
Yeah, oftentimes an attack from an activity group can look like magic unless you understand the steps involved and the technologies involved. So the attack for ICS and attack for enterprise really takes the magic out of it when you can see the steps involved and the technical details of what these techniques entail. It really breaks it down beautifully. So it takes all of the air of magic and wizardry out of it when you start to use that common taxonomy and have that conversation based around the attack matrix.
All right, and with that, we are just at the hour. Just wanted to say thank you to everyone who participated today. Awesome question and answer time at the end. I want to thank Kurt and Austin. And again, we will be sending out the recording and slides over the next couple days, so definitely look out for that. Again, thanks a lot, and we look forward to you joining our next webinar. You will get some information about that in the email to come. Thanks again, and have a good day.
Thank you all.